Right, here we're draining the tank using Torricelli's law that the rate of flow is proportional to the square root of the depth. So we start with a tank 10 feet tall. It's a cone, and the height here is 10 also. So the first thing we want to figure out is the volume of this when the height is that. So A, volume of water or whatever liquid we're working with. Well, the area of a cone is 1/3 height times area of the base, and that's going to be 1/3. This time we're using y to be the height, and what's maybe slightly trickier is to figure out the area of the base. Well, that's going to be pi r squared. Well, how are y and r related? Well, it's a straight line relation. Let's put r and y here. And we can see that one point on this line is 10, 10. So this just says that y is equal to r. So this is going to be 1/3 pi y cubed. So, okay, now let's figure out the differential equation. So what that is d dt of the volume is going to be some constant of proportionality times the square root of y. Well, this is then d dt of 1/3 pi y cubed is minus k. Let's write it as y to the 1/2. So taking derivatives here, this is 1/3 pi times 3y squared, and then times y prime is minus k y to the 1/2. So this now is let's see, the 3's cancel, that's nice. So I get pi y squared, let's write the derivatives, dy dt is minus k y to the 1/2. This is now a separable equation, so I can write it as pi, subtracting the half from the 2, I get y to the 3/2 dy, and I get minus k dt. So integrating pi y cubed over 2 dy is minus k integral dt. Let's see. So this is going to be pi y to the 5/2. I'm going to multiply by that when I take the derivative, so I'll get an antiderivative. I need to cancel it out with a 2/5. And that is going to be minus kt plus a constant of integration. So y to the 5/2 is c over 2 pi over 5, dividing through that, minus k over 2 pi over 5 t, And let's simplify our notation a little bit and just call that C1 minus K1 T. And then this gives me that Y is raising both sides to the 2/5 power. This gives me C1 minus K1 T to the 2/5. And now to figure out the constants, Y of 0 is C1 minus 0 to the 2/5, and that is 10. So C1 is 10 to the 5/2. So, and Y of, what was it? Y of 5. Let me check to make sure I have that right. Let's just scroll back up and look. Y of 5 is 9, yes. Y of 5 equals 9, and that is C1 minus K1 times 5 to 2/5. So 9 to the 5/2 is C1 minus K minus, let's write it as 5K1. So K1 is going to be bringing, let's see, well, let's bring this over. 5, I'm going to have C1 minus 9 to the 5/2. So K1 is C1 minus 9 to the 5/2 over 5, which is 10 to the 5/2 minus 9 to the 5/2 over 5, which turns out to be 14.646, and our C1, which was 10 to the 5/2, is 316.228. So giving our final formula for Y to be C1 minus K1 T to the 2/5 equals 316.23 minus 14.65 times T to the, I'm sorry, I've got the power wrong there, to the 2/5. And we wanted to know how long it took it to drain, so we want to solve Y equals 0, which is going to be C1 minus K1 T to the 2/5, which is going to give T equals C1 over K1, and plugging that in turns out to be 21.592 minutes.